It tells us that Sam needs to hire a manager. It gives us the manager's utility function, where it's a function of the wealth that they get or their salary and the cost of their effort. It tells us that they have a next best job where they can earn $90,000 and low effort is acceptable. And with low effort, the cost of effort is 0. And with high effort, the cost of effort is 200. It then goes on to tell us that there's a 70% chance the firm will make high profit if the manager works hard. And it tells us that we're going to pay the manager based on our profit. So profit is our signal in order to pay the manager, to decide whether to give him a high wage or a low wage. If we make high profits, we'll pay him a high wage, which is 70% of the time, if he works hard, of course. If we make low profits, we're going to pay him a low wage. So what it's saying is, if he works hard, there's a 70% chance he's going to get that high wage, and there's a 30% chance, even though he worked hard, he's going to get that low wage because we'll have low profits. And the question says, how much higher is the expected cost of the manager's earnings to the firm in the presence of moral hazard, which is unobservable effort, than if there were perfect information? So basically, when you think of moral hazard, there's a couple of examples you can think of, but unobservable behavior is working or shirking. And if we're not watching them, we're going to think that moral hazard is the idea that they're going to shirk because they're not being watched. So we need to compensate them such that it's going to incentivize them to work hard, even though we can't watch them. That's when there's moral hazard. If there's not moral hazard, that means there's perfect information. You can imagine that as if the owner is with the manager all day long, every day, and he can see if he's working hard or not. So with perfect information, again, that's without moral hazard, we're going to assume that the guy's going to work hard for sure because we're watching him. So first let's solve what his salary would have to be to work at our firm if there were perfect information. So we'll call that with certainty. And with certainty, we just need to make sure that the wage we pay him, so we need to plug that into his utility function, minus the cost of his effort, is going to be greater than or equal to his next best job, which was where he made a wage of $90,000. Low effort was acceptable, so we know we minus away 0 at the end because there's no cost of effort at his other job. We can plug in what we know. We know that the cost of effort at working hard at our job is 200. We can go ahead and set those equal instead of the greater than or equal to just to solve. But we remember that if you want to think about it, one more dollar on the left side, so he definitely will work with us. But again, we're going to set it equal to solve. So now we have the square root of our wealth minus 200 must be equal to 300. And the 200 and 300 are already in units of utility, which is important to understand. So that CE can be looked at as the disutility of effort. We work that out, and we see that the wage that we'd have to pay him with perfect information is $250,000. So now let's take a look at with uncertainty. Well, with uncertainty, we call that moral hazard. We don't know if he's going to work hard for sure. We know that we can incentivize him to do so based on his wage that he'll get if profits are high and the wage that he'll get if profits are low. So now we need to figure out the constraints. In this case, we have a participation constraint. This says this constraint is aimed at just making him work with us opposed to his other job. So just like it sounds, participation, which is like, come participate in our firm. So on the left side, we're going to be comparing high effort at our job, and we're going to want to make that greater than or equal to his other job. Well, high effort at our job, well, that'll be 70% of the time that high effort will result in high profits, and he'll get paid the high wage. 30% of the time that high effort won't result in high profits, and he'll get paid that low wage. And we know that that cost him $200 for his disutility of effort. So on the left side, we have him working hard at our job. On the right side, we have his other job, his next best alternative, which we know he got $90,000 for sure. And again, the cost of effort there was 0. The selection constraint, well, now that we have him at our firm, because the participation constraint took care of that, it made him participate in our firm. The selection constraint is aimed at making him work hard. So on the left side, again, we're going to have high effort at our job, but now we're going to make that greater than or equal to low effort at our job. So now the selection constraint is going to incentivize him when he's at our job to actually work hard. And again, all these constraints we're going to set equal to solve, but think of them as greater than or equal to, because that really represents the right picture. So high effort at our job is going to look exactly the same. Low effort at our job, well, with low effort, it said there's a 0% chance of high profit. So we know with 100% certainty he's going to make the low wage, and we know that it costs him 0. Real fast, if for some reason there was a probability of high profit even with low effort, we'd have to include that. So be careful you understand this. Right now on the left side we have just this WL by itself minus 0. That's because there's a 100% chance they're going to make low profit with low effort. Let's say there was a 20% chance they'd make high profit. Well, then we'd have 0.2 times WH to the 0.5 plus 0.8 times WL to the 0.5 minus that 0. So just make sure you understand that this is a special scenario where there's a 0% chance of making high profit with low effort. And that's why the right side looks like this. Well, now we can use our constraints. We have two constraints. We can use these constraints together to solve for WL and WH. What we notice is both of these left sides look exactly the same. And the right side, the only thing that's different is there's a 90,000 there and a WL there. So we know that WL is going to equal 90,000, right? Because we know that they're all equal. We're setting them equal, the constraints. And the left sides are exactly the same. So the right sides must be exactly the same. And 90,000 raised to the 0.5 is then therefore equal to WL raised to the 0.5. Therefore, WL is equal to 90,000. Well, so we can go ahead and plug in what we know for WL into our first constraint to solve for WH. We do this and we work through the math, and we see that after we've done some algebra that WH is going to be equal to $343,061.22. So now we need to figure out what is the expected wage of this employee, of this manager. Well, we know that if we have low profit, we're going to pay him $90,000 because we'll pay him the low wage. If we have high profit, we're going to pay him $343,000 roughly because we had high profit. We'll pay him the high wage. How do we figure out our expected cost to the firm, which is the manager's expected salary? Well, there's a 30% chance we're going to have that low profit. There's a 70% chance we're going to have that high profit. So we just multiply those through and add, and we see that our expected wage in this case is $267,142.857. So now the question was asking us the difference between basically the cost of moral hazard to the firm. The difference between the salary that we pay him if we had perfect information and the salary we expect to pay him if we don't have perfect information or in the face of unobservable behavior. Well, with certainty, we found that our wage was going to be $250,000 for sure. And the cost due to moral hazard, therefore, is the difference between that $267,000 minus the $250,000. In this case, it's roughly $17,000 is the cost of moral hazard to the firm.